functions is odd. And so just let's remind ourselves what it means for a function to be odd. So I have a function, well, they've already used f, g, and h, so I'll use j. So a function j is odd if you evaluate j at some value, so let's say j of a, and if you evaluate that j at the negative of that value, and if these two things are the negative of each other, then my function is odd. If these two things were the same, if you didn't have this negative here, then it would be an even function. So let's see which of these meet the criteria of being odd. So let's look at f of x. So we could pick a particular point. So let's say when x is equal to 2. So we get f of 2 is equal to 2. Now what is f of negative 2? F of negative 2 looks like it is 6. F of negative 2 is equal to 6. So these aren't the negative of each other. In order for this to be odd, f of negative 2 would have had to be equal to the negative of this, would have had to be equal to negative 2. So f of x is definitely not odd. So all I had to do is find even one case that violated this constraint to be odd, and so I can say it's definitely not odd. Now let's look at g of x. So let's look at g of x. So I can use the same, let's see, when x is equal to 2, we get g of 2 is equal to negative 7. Now let's look at when g is negative 2. So we get g of negative 2. G of negative 2 is also equal to negative 7. So here we have a situation, and it looks like that's the case for any x we pick, that g of x is going to be equal to g of negative x. So g of x is equal to g of negative x. It's symmetric around the y, or I should say the vertical axis right over here. So g of x is even, not odd. So which of these functions is odd? Definitely not g of x. So our last hope is h of x. Let's see if h of x seems to meet the criteria. So if I'll do it in this green color. So if we take h of 1, and we can look at it even visually. So h of 1 gets us right over here. H of negative 1 seems to get us an equal amount, an equal distance, negative. So it seems to fit for 1. For 2, well, 2 is at the x-axis, but that's definitely h of 2 is 0, h of negative 2 is 0, but those are the negatives of each other. 0 is equal to negative 0. If we go to, say, h of 4 is this negative number, and h of negative 4 seems to be a positive number of the same magnitude. So once again, this is the negative of this. So it looks like this is indeed an odd function. And another way to visually spot an odd function is a function is going to go through the origin, and you could essentially flip it over on both axes. So if you flip this, the right half over the left half, and then flip that over the horizontal axis, you are going to get this right over here. So you see here we're going up and to the right, here we're going to go down and to the left, and then you curve right over there, you curve up just like that. But the easiest way to test it is just to do what we did. Look at a given x. So for example, when x is equal to 8, h of 8 looks like this number right around 8. H of negative 8 looks like it's pretty close to negative 8. So they seem to be the negative of each other.
Line passes through the points negative 3, 6, and 6, 0. Find the equation of this line in point slope form, slope intercept form, standard form. And the way to think about these are just 3 different ways of writing the same equation. So if you give me one of them, we can manipulate it to get any of the other ones. But just so you know what these are, point slope form, let's say the point x1, y1 let's say that is a point on the line. And when someone puts this little subscript here, so if they just write an x, that means that we're talking about a variable that can take on any value. If someone writes x with a subscript 1 and a y with a subscript 1, that's like saying a particular value of x, a particular value of x and a particular value of y, or a particular coordinate. So then you'll see that when we do the example. But point slope form says that, look, if I know a particular point, and if I know the slope of the line, then putting that line in point slope form would be y minus y1 is equal to m times x minus x1. So for example, and we'll do that in this video, go. If the point negative 3 comma 6 is on the line, then we say y minus 6 is equal to m times x minus negative 3. So it'll end up becoming x plus 3. So this is a particular x and a particular y. It could be a negative 3 and 6. So that's point slope form. Slope intercept form is y is equal to mx plus b, where once again m is the slope, b is the y-intercept. Where does the line intersect the y-axis? What value does y take on when x is 0? And then standard form is a form ax plus by is equal to c, where these are just two numbers, essentially. They really don't have any interpretation directly on the graph. So let's do this. Let's figure out all of these forms. So the first thing we want to do is figure out the slope. Once we figure out the slope, then point slope form is actually very, very, very straightforward to calculate. So just to remind ourselves, slope, which is equal to m, which is going to be equal to the change in y over the change in x. Now, what is the change in y? If we view this as our endpoint, if we imagine that we're going from here to that point, what is the change in y? Well, we have our endpoint, which is 0. Y ends up at 0, and y was at 6. So our finishing y point is 0. Our starting y point is 6. What was our finishing x point, or x coordinate? Our finishing x coordinate was 6. Let me make this very clear. I don't want to confuse you. So this 0, we have that 0. That is that 0 right there. And then we have this 6, which was our starting y point. That is that 6 right there. And then we want our finishing x value. That is that 6 right there, or that 6 right there. And we want to subtract from that. We want to subtract from that our starting x value. Well, our starting x value is that right over there. That's that negative 3. That's that negative 3. And just to make sure we know what we're doing, this negative 3 is that negative 3 right there. I'm just saying, how much if we go from that point to that point, our y went down by 6, right? We went from 6 to 0. Our y went down by 6. So we get 0 minus 6 is negative 6. That makes sense. Y went down by 6. And if we went from that point to that point, what happened to x? We went from negative 3 to 6. It should go up by 9. And if you calculate this, take your 6 minus negative 3. 6 minus negative 3, that's the same thing as 6 plus 3. That is 9. And what is negative 6 ninths? Well, if you simplify it, it is negative 2 thirds. You divide the numerator and the denominator by 3. So that is our slope, negative 2 thirds. So we're pretty much ready to use point slope form. We have a point. We could pick one of these points. I'll just go with the negative 3, 6. And we have our slope. So let's put it in point slope form. So point slope form. Point slope form. All we have to do is we say y minus, now we could have taken either of these points. I'll take this one. So y minus the y value over here. So y minus 6 is equal to our slope, which is negative 2 thirds, times x minus our x coordinate. Well, our x coordinate, so x minus our x coordinate is negative 3. X minus negative 3, and we're done. We can simplify it a little bit. This becomes y minus 6 is equal to negative 2 thirds times x. X minus negative 3 is the same thing as x plus 3. This is our point slope form. Now, we can literally just algebraically manipulate this guy right here to put it into our slope intercept form. Let's do that. So let's do slope intercept in orange. So we have slope intercept. So what can we do here to simplify this? Well, we can multiply out the negative 2 thirds. So you get y minus 6 is equal to, I'm just distributing the negative 2 thirds. So negative 2 thirds times x is negative 2 thirds x. And then negative 2 thirds times 3 is negative 2. And now to get it in slope intercept form, we just have to add the 6 to both sides, so we get rid of it on the left-hand side. So let's add 6 to both sides of this equation. Left-hand side of the equation, we're just left with a y. These guys cancel out. you get y is equal to negative 2/3 x, negative 2/3 x. Negative 2 plus 6 is plus 4. So there you have it. That is our slope-intercept form, mx plus b. That's our y-intercept. Now, the last thing we need to do is get it into the standard form. Get it into standard form. Standard. So once again, we just have to algebraically manipulate it so that the x's and the y's are both on this side of the equation. So let's just add 2/3 x to both sides of this equation. So I'll start here. So we have y is equal to negative 2/3 x plus 4. That's slope-intercept form. Let's add 2/3 x. So plus 2/3 x plus 2/3 x to both sides of this equation. Plus 2/3 x. I'm doing that so I don't have this 2/3 x on the right-hand side. It's negative 2/3 x. So the left-hand side of the equation, I squunched it up a little bit, maybe more than I should have. The left-hand side of this equation is what? It is 2/3 x, because 2/3x plus this y, that's my left-hand side, is equal to, these guys cancel out, is equal to 4. So this by itself, we are in standard form. This is the standard form of the equation. If we wanted to make it look extra clean, have no fractions here, we could multiply both sides of this equation by 3. If we do that, what do we get? 2/3 x times 3 is just 2x. Y times 3 is 3y. And then 4 times 3 is 12. These are the same equations. I just multiplied every term by 3. If you do it to the left-hand side, you do it to the right-hand side, or you have to do it to the right-hand side. And we are in standard form.
We are asked which of these lines are perpendicular. It has to be perpendicular to one of the other lines. You can't be just perpendicular by yourself. And perpendicular lines, just so you have a visualization for what perpendicular lines look like, two lines are perpendicular if they intersect at right angles. So if this is one line right there, a perpendicular line will look like this. A perpendicular line will intersect it, but it won't just be any intersection. It will intersect at right angles. It will intersect at right angles. So these two lines are perpendicular. Now, if two lines are perpendicular, if the slope of this orange line is m, so let's say its equation is y is equal to mx plus, well, let's say it's b1, so it's some y-intercept, then the equation of this yellow line, its slope is going to be the negative inverse of this guy. This guy right here is going to be y is equal to negative 1 over mx plus some other y-intercept. Or another way to think about it is if two lines are perpendicular, the product of their slopes is going to be negative 1. And so you could write that there. M times negative 1 over m, negative 1 over m, that's going to be, these two guys are going to cancel out. That's going to be equal to negative 1. So let's figure out the slopes of each of these lines and figure out if any of them are the negative inverse of any of the other ones. So line A, the slope is pretty easy to figure out. It's already in slope-intercept form. Its slope is 3. So line A has a slope of 3. Line B, it's in standard form. Not too hard to put it in slope-intercept form. So let's try to do it. So let's do line B over here. Line B, we have x plus 3y is equal to negative 21. Let's subtract x from both sides so that it ends up on the right-hand side. So this, we end up with 3y is equal to negative x minus 21. And now let's divide both sides of this equation by 3. By 3. And we get y is equal to negative 1/3 x minus 7. So this character's slope is negative 1/3. So here m is equal to negative 1/3. So we already see they are the negative inverse of each other. You take the inverse of 3, it's 1/3, and then it's the negative of that. Or you take the inverse of negative 1/3, it's negative 3, and then this is the negative of that. So these two lines are definitely, those two lines are definitely perpendicular. Perpendicular. Let's see this third line over here. So line C. Line C is 3x plus y is equal to 10. If we subtract 3x from both sides, we get y is equal to negative 3x plus 10. So our slope in this case is -3. So our slope here is equal to -3. Now this guy is the negative of that guy. This guy's slope is the negative of that, but not the negative inverse. So it's not perpendicular. And this guy is the inverse of that guy, but not the negative inverse. So this guy is not perpendicular to either of the other two, but line A and line B are perpendicular to each other.
Whereas which of these lines are parallel? So they give us three equations of three different lines. And if they're parallel, then they have to have the same slope. So all we have to do over here is figure out the slopes of each of these lines. And if any of them are equal, they're parallel. So let's do line A. Line A, it's 2y is equal to 12x plus 10. We're almost in slope-intercept form. We can just divide both sides of this equation by 2. Let's divide all the terms by 2. We get y is equal to 6x, right? 12 divided by 2. 6x plus 5. So our slope in this case, we have it in slope-intercept form. Our slope in this case is equal to 6. Let's try line B. Line B is y is equal to 6. Now this might be, you might say, hey, gee, this is a bizarre character. How do I get this into slope-intercept form? Where's the x? And my answer to you is that it already is in slope-intercept form. I can just rewrite it as y is equal to 0x plus 6. The x term is being multiplied by 0 because the slope here is 0. Y is going to be equal to 6 no matter how much you change x. Change in y is always going to be 0. It's always going to be 6. So here, our slope is 0. Our slope is equal to 0. So these two lines are definitely not parallel. They have different slopes. So let's try line C. Line C, I'll do it down here. Line C. So that's y minus 2 is equal to 6 times x plus 2. And this is actually in point slope form, where the point x is equal to -2, y is equal to 2. So the point -2 is being represented here because you're subtracting the points. And the slope is 6. So we already know that the slope is equal to 6. And sometimes people are more comfortable with slope-intercept form. So let's put it in slope-intercept form just to confirm that if we put it in this form, the slope will still be equal to 6. So if we distribute this 6, we get y minus 2 is equal to 6 times x, 6x plus 6 times 2 is 12. And then if you add this 2, if you add 2 to both sides of the equation, you get y, because these guys cancel out, is equal to 6x plus 14. So you see, once again, the slope is 6. So line A and line C have the same slope. So line A and line C are parallel, and they're different lines. If they had the same y-intercept, then they would just be the same line. X plus 5 squared plus y minus 5 squared equals 4. I know what you're thinking, what's all of this silliness on the right-hand side? This is actually just the view we use when we're trying to debug things on Khan Academy. But we can still do the exercise. So it says drag the center point and perimeter of the circle to graph the equation. So the first thing we want to think about is, well, what's the center of this equation? Well, standard form of a circle is x minus the x-coordinate of the center squared plus y minus the y-coordinate of the center squared is equal to the radius squared. So x minus the x-coordinate of the center. So the x-coordinate of the center must be -5, because the way we can get a positive 5 here is by subtracting a -5. So the x-coordinate must be -5. And the y-coordinate must be +5, because it's y minus the y-coordinate of the center. So y-coordinate is +5. And then the radius squared is going to be equal to 4. So that means that the radius is equal to 2. And the way it's drawn right now, we can drag this out like this. But this, the way it's drawn, the radius is indeed equal to 2. And so we're done. And I really want to hit the point home of what I just did. So let me get my scratch pad out. So this, sorry for knocking the microphone just now. So that equation was x plus 5 squared plus y minus 5 squared is equal to 4 squared. And so I want to rewrite this as, this is x minus -5. X minus -5 squared plus
writing it as 4, I'll write it as 2 squared. And so this right over here tells us that the center of the circle is going to be x equals -5, y equals 5, and the radius is going to be equal to 2. And once again, this is no magic here. This is not just, I don't want you to just memorize this formula. I want you to appreciate that this formula comes straight out of the Pythagorean theorem, straight out of the distance formula, which comes out of the Pythagorean theorem. Remember, if you have some center, in this case, it's the point -5, 5. So -5, 5. And you want to find all of the x's and y's that are 2 away from it. So you want to find all the x's and y's that are 2 away from it. So that would be one of them. X, y. This distance is 2. And there's going to be a bunch of them. And when you plot all of them together, you're going to get a circle with radius 2 around that center. But let's think about how we got that actual formula. Well, the distance between that coordinate, between any of these x's and y's, it could be an x and y here, it could be an x and y here, and this is going to be 2. So we could have our change in x. So we have x minus -5. So that's our change in x between any point x, y, -5, 5. So our change in x squared plus our change in y squared. So that's going to be y minus the y coordinate over here squared is going to be equal to the radius squared. So the change in y is going to be from this y to that y. This is the end point. The end minus the beginning, y minus 5. Y minus 5 squared. And so this shows for any xy that is 2 away from the center, this equation will hold. And it becomes, I'll just write this in neutral color, x plus 5 squared plus y minus 5 squared is equal to the radius squared is equal to 2, or let me just write that, is equal to 4. And let me make it, I really want to, I dislike it when formulas are just memorized and you don't see the connection to other things. Notice we can construct a nice little right triangle here. So our change in x is that right over there. So that is our change in x, and our change in y, not the change in y squared, but our change in y is that right over there, change in y, you could view that as y minus y, so this is change in y is going to be y minus 5, and our change in x is x minus -5. X minus -5. So this is just change in x squared plus change in y squared is equal to the hypotenuse squared, which is this radius. So once again, comes straight out of the Pythagorean theorem. Hopefully that makes sense.
We're going to do a direct, inverse, and joint variation on this part. So there's no board problem with this. You saw that in the last one right here. So direct variation is this, you guys. If y varies directly as x, if you see those words right there, then you have this equation, y equals kx. And k is called the constant of variation. Okay, so let's see. Suppose y varies directly as x, and y equals 27 when x equals 6. Find the constant of variation and write an equation of the form y equals kx. And then we're going to use that equation for number 2 to find y when x equals 10. All right, let's go ahead. Since y equals kx, you guys, since they told me y varies directly, y equals kx, so I plugged in 27 for y and then 6 for x, so 27 equals k times 6, and then divide both sides by 6, you get k equals 4.5, so that's my constant of variation. And then now my equation is then y equals 4.5 times x. It said first find the constant of variation and then write the equation. Okay. Now we're going to use this equation, y equals 4.5x, and plug in x equals 10 right there. All right. So 4.5 times 10, you get 45. Okay. So G says if y varies directly as the cube of x cubed, and y equals negative 67.5 when x equals 3. Find x when y equals negative 540. Okay, remember, y equals kx. So that negative, in this case, y equals k times x cubed because it's the cube of x. All right. So what I had to do is, remember, you got to watch that word cube right there. Sometimes it says square root, so it'd be square root. So just watch the wording. So there's y, there's x, but it's being cubed, you guys. Okay, so that's 3 cubed is 27. So I'm going to divide both sides by 27, and I get k to be negative 2.5. So here's my equation. Y equals negative 2.5x. Y equals kx. Okay, so now it says find x when y is negative 540. So I put in negative 540 for that, and then divided both sides by negative 2.5, and I got 216. All right, inverse variation is if y varies inversely, then you use the equation y equals k over x. All right, so same stuff, except you just do y equals k over x. So here we go. If y varies inversely as x, so y equals k over x, and y is 21 when x is 15, find x when y is 12, okay? So I'm going to go ahead and do 21 equals k over 15, multiply both sides by 15, I get 315 equals k. So here's my equation, y equals 315 over x. And then it says find x when y is 12. So that means 12 equals 315 over x. Multiply both sides by x, I get 12x equals 315. So we get 26.25. Okay? So inverse is y equal k over x. Direct is y equal kx. Okay? Jointly means if y varies jointly with x and z, then you use y equals, it's just like direct variation, you guys. Direct means jointly, except it's direct with a couple of things. So y equals kxz. All right, let's try one of these with these little guys here. So if y varies jointly as x and z, and inversely as the square of w, and y equals 15, x equals 3, let's see, z equals 10, w equals 2. That's a lot. Find y when x equals 4, z equals 20, and w equals 4. Okay, so since it's inversely means it goes downstairs. Okay, so it's inversely as the square of w. So the w squared goes downstairs because it's inverse. And it's jointly, so k times xc goes on top. And then now it's just fill it in. So this 15 is going to go right here. This x is going to go here, this z is going to go here, and the w is going to be 2 squared, goes down there, and then we solve for k. Okay, and I get k equals 2. So now I know it's this, y equals 2x y over w squared. And then you fill in that second half of the part right there, and you end up getting 10 on that. All right.